Laval on the beautiful building that you see there. And the jury is proud to have elected as our president. And now let me introduce you the president of the jury for that defense, that amazing defense. It's Stéphanie Buzine. She's professor at Thesis Graduate School of Engineering. And thank you to have accepted to be the president of that international jury. Then it's up to you, Stéphanie.
Thank you, Simon. Good morning, everybody. Welcome to this PhD defense. So actually, I'm very glad to serve today as the president of this beautiful jury. And I will first introduce the members of the jury. First, we have the two external reviewers who gave particular attention in examining the work of Abdul Rahman Abdel Razek. And the two external reviewers are Professor Kulwant Pawar, who is a full professor at Nottingham University Business School.
Good morning.
Thank you. The second external reviewer is Professor Devi Monticolo, full professor at University of Lorraine.
Hello, everyone.
Thank you. Then we have two examiners. First, Dr. Laurent Dupont, research engineer at University of Lorraine.
Hello.
And Dr. Olivier Chrisman, associate professor here at Arts et Métiers School of Engineering.
Hello.
Then we have the supervising team with Professor Dr. Christian van Huizen from Furtwangen University in Germany.
Hello, good morning from Germany.
We also have in the supervising team Dr. Marc Palot, Senior Research Associate at Arts et Métiers School of Engineering.
Good morning from Paris.
And finally, last but not least, Professor Simon Richir, full professor here at Arts et Métiers School of Engineering, and me as the president of the jury. So now we will, everybody, the jury members, please, we will switch off the cameras and also the microphones. And we will now listen to our PhD candidate of the day, Abdul Rahman Abdel Razek, who will present his work for about 45 minutes. So now it's your turn, and see you after the presentation.
Thank you very much, Madam President, esteemed members of the jury. I think most of us, when we go into a meeting and we try to explain an idea, especially to colleagues, to other project stakeholders, we try to explain the idea, but most of the time we realize that either they totally misunderstood the idea or vice versa, they are trying to explain an idea to us and we totally misunderstood the idea. So this miscommunication is due to the fact that we try to represent an idea, but somehow it doesn't come exactly like we want to represent it in our mind. One of the most important things in creating a representation of the idea is prototyping. Prototyping could be coming form in a product prototype, a process prototype, a service prototype, anything prototype. So you can take any kind of idea, create a physical representation, even a verbal representation, even a digital representation, to be able to have a common understanding of this idea. So by using prototyping, we can take an idea and create an understanding of this idea. And by using technologies like immersive technologies like virtual reality, augmented reality, and mixed reality, you can have this digital representation and you can have an experience on it. So that got us to look at what kind of impacts would these immersive technologies have on service prototyping, to be able to understand more about what kind of impacts and how did we deduce these impacts. I devised a small visual abstract to give you a better idea about this. So investigating the performance, experience, and intention to adopt of different service prototypes. So we compared different forms of service prototyping to be able to see which one performed better in terms of effectiveness, in terms of experience, and in terms of intention to adopt. We compared 5 forms of service prototypes, 3 immersive and 2 traditional ones. This is the view from inside the virtual reality-based service prototype. As you can see, this is the sequence that the participants have to recreate in the physical world, and they are getting the information in the virtual world. Same thing in the augmented reality-based service prototype, where they have the instruction step-by-step guide. And also by using mixed reality-based, where they have the step-by-step guide in a hologram form, where they air tap to get the next step. We have also the video-based prototype, where they have a video of the replication of the task, where someone is performing the task so they can replicate it. We also have a paper-based prototype, where they have instruction manual, a traditional instruction manual in paper form. After each use of service prototype, the participants filled out a bipolar survey. And now it's time to know which service prototype performed best. The motivation for this dissertation, in 2015, I was working as a service lab manager in the University of Furtwangen with Christian, and we were in the process of proposing a project about multidimensional service prototyping with 7 industrial partners, University of Furtwangen as the coordinator, and we had also a research partner. And we won the proposal from the BMBF with an investment funding of 2.5 million euros for 3 years, where we explore the application of service prototyping in an industrial setting. And in 2016, also service prototyping was an emerging trend, and a lot of companies started looking at what could they use in their service development that could improve their service development. And many of these companies also looked at what kind of technologies they could use. And also I observed that there is a rising interest in use of service prototyping and immersive technologies, both in the academic and in the industrial world. The purpose of this dissertation is to create a standard to help engineers, designers of services to be able to leverage service experience for service development. Also to be able to support the service stakeholders when they are sitting together in creating a service or creating a prototype of a service, to be able to reach a common understanding. At the same time, to have a better way of decision making and to allow internal stakeholders to have training even before the service exists. Also, we aim to improve the learning environments through service prototyping, because by using service prototyping, we create a learning by experience atmosphere and having the ability to iteratively improve the design and improve on the idea. Our research objective was to first to identify what kind of potential challenges might arise from the use of immersive technologies on service prototyping, and to see what kind of definitions could be missing in service prototyping and in immersive technologies used in service prototyping. We also had to categorize the service prototyping forms, as there was no categorization before. We also defined and compared the service prototyping form. We also evaluated the impacts that immersive technologies has, whether virtual reality, augmented reality, or mixed reality, on the service prototyping experience, performance, and the degree of adoption. Also to deduct then the benefits and the drawbacks that the use of immersive technologies will have on service prototyping. So why did we choose immersive technologies? We expected several things from immersive technologies. We expected that the immersive technologies would allow us to freely explore service ideas as if you are wearing a virtual reality glasses, you will be able to perceive another world that you are in, so you'd be able to explore the idea from other perspective. Also, it will enhance the feedback to and from the stakeholders, as the stakeholder would be able to see exactly what idea you are talking about. And it will also improve the service activities, as you can use immersive technology to supplement such activities such as training or maintenance. Looking at the literature review, we have 8 main research domains, which are service engineering, innovation, design, user experience, and XR industrial assembly. These are the main domains, and we can see that our main research scope is concerned with service prototyping in maintenance assembly. And this includes also the immersive service prototyping experience. So talking about the immersiveness is being deeply engaged, fully observed in solving a problem. So even if I'm reading a book and the book is really engaging, then I'm immersed into this book. Immersion could come in many forms. The 3 forms that we concentrated on are the perceptual immersion, the immersion that happens perceptually, emotional immersion, and cognitive immersion. And we have to also consider that the immersion means sense of being somewhere where you are not. Feeling that you are physically there while you are actually somewhere else. And this means that it is very vital to evaluate the experience, is to evaluate the immersiveness as well. So we created a main research question that gives us an idea about what would our main objective be, and that's what are the impacts of immersive technologies on service prototyping. And through this main research question, we created 5 sub-questions. The first sub-question is, what are the impacts of immersiveness on the perception of time of the stakeholder, on their attentiveness to their surroundings, and to their responsiveness to their external events. The second research question is concerning the impacts of immersiveness on the stakeholders' service prototyping experience. And the third research question concerning immersiveness is on the service prototyping effectiveness, and how useful is the prototype, how user-friendly is it, and how pleasant is it. The fourth research question asks, what are the impacts of service prototyping effectiveness on the stakeholder service prototyping experience? Last but not least, the fifth research questions focuses on the impacts of the service prototyping experience on the intention to adopt such form. Looking at the proposed hypotheses, we have 5 hypotheses. We hypothesized that the deeper the immersiveness, the higher the real-world association will be. We also hypothesized that the deeper the immersiveness, the more satisfying the service prototyping experience for the stakeholder. And also the deeper the immersiveness, the higher the service prototyping effectiveness. And if we look at the fourth hypothesis is that the higher the effectiveness, the more satisfying the service prototyping experience, and the more satisfying the prototyping experience, the higher the intention to adopt. There were many interesting and relevant papers, but the most relevant papers for service prototyping were in these 5 domains: the process optimization, the design improvement, the methodology, the training comparisons, and also the focus in the XR assembly studies were on comparing different assembly and instructional guidance, comparing also the experiments that were done with XR assembly guidance and the testing with XR assembly guidance. Especially these 2 publications were very interesting, as well as we will see why in the next slide. So, through the literature review, several gaps were identified in the literature. There were no definitions found on immersive service prototyping, including virtual reality, augmented reality, and mixed reality-based service prototypes. And there was no definition also found for the service prototype experience. There were also lack of characterization of service prototyping forms. There wasn't any mention of conventional and immersive service prototypes. The terms itself, conventional service prototype and immersive service prototypes, is brand new. There were also lack of empirical studies in the literature, except for these two publications that I highlighted in the previous slide, as one was published late 2019 and the other one was published early 2020. There was also lack of empirical studies regarding immersive technologies' impact on service prototyping. There was no authors that focused on what kind of impacts that immersive technologies bring on service prototyping. So to be able to bridge the gap that I just mentioned, I have to mention a couple of definitions that will help us understand. Services, as we all know, is an intangible thing. So services could come in form of a maintenance process. It could come in form of a training process. So creating a prototype from a service is creating an experience from an intangible thing. So to create this, to develop this service, we have to use an idea or use a representation of this service and create an experience. This experience will allow stakeholders to explore this idea and then evaluate it and, of course, communicate this idea. And all this even before the service exists. And this allows us to create an experience or a real experience from an intangible idea. And you can get an idea, create this representation from it, and this representation creates an experience that creates a perception in the user. This perception creates a reaction, and through the reaction, we have feedback that continuously improves the idea. Looking at the service prototyping experience, there was no definition of the term, so we looked at the most relevant experience definitions. We looked at customer experience, we looked at service experience, we looked at user experience, we looked at the term experience itself, and we deduced a definition for service prototype experience that encompasses the whole experience of the service prototyping process, including all the retained knowledge that occurs during the process, everything that is individual impressions and observation, whether it's perceived or sensed. And basically, a service prototyping experience is one moment or a part of the service prototyping experience. So more than one service prototyping experience or a collection of these moments together would create a complete service experience. So, as I mentioned before in the gap, there was also no characterization or categorization of service prototyping forms. We categorize service prototypings into two forms. First, the conventional service prototypes. We have the verbal-based service prototype, so a verbally based one, paper-based, so we have paper-based, a mock-up-based, which could be a physical mock-up or a video mock-up, and a simulation-based, which could be a simulation like in a 360-degree display. We have also immersive service prototypes, where we have virtual reality-based service prototype by using virtual reality head-mounted displays, augmented reality-based service prototypes by using tablets or mobile phones, and mixed reality-based service prototypes by using mixed reality glasses like the HoloLens. We will be focusing only on these two conventional and these three immersives. And by doing that, we created a research model that shows us the relationships between the UX properties like the intuitiveness, interactivity, perception of time, and the constructs like the immersiveness, which is the higher construct. And we can see also the causality effect and the hypotheses where they connect to each other. We also created a research instrument, which was instrumental in creating the survey. The model was statistically validated, and that's why we were able to go to the next step, which is creating the experiment. So the experiment is basically having to disassemble and assemble a three-part method construction. It might look simple, but this method construction has a unique thing that is every angle of each part is different. So each part will only fit in a unique position and in only one order, so you have to fit it exactly in the same order and in exactly the same position. And we had 5 different instructional service prototypes. We had the paper-based one, a paper leaflet. We had a video replication of the process, someone replicating the process so the participant would be able to see it and then replicate it. We have a virtual reality-based one where they go into the virtual reality and they see an animation of step-by-step instructional guide to be able to disassemble and assemble. We have augmented reality-based instructional manual where they have step-by-step instructional manual with connected to the augmented reality markers. And we have a mixed reality based service prototype where they can air tap step by step, getting a holographic instructional manual. We created a test to test all these devices and test the process of the experiment. And we created a baseline experiment to have a benchmark. Benchmark here meaning is that we had 30 participants that disassembled and assembled this 3-part construction, but without using any kind of service prototypes. So the service prototyping experiment is to validate the hypotheses. We used, as I said, that they fill out a bipolar survey after each use of service prototype. So looking at the experimentation of the test, we had looked at how long will the experiment take, because we plan to have more than 100 participants, so we had to have a time or duration of the experiment that's not too long and not too short to keep the interest of the volunteer, because they were all volunteers, the participants. We had to look also on the process and the devices, which devices are going to be used. I can highlight here is that you can see on the right side the picture for the test experiment, and actually we changed a couple of things due to the test experiment. First, we changed the head-mounted display, the virtual reality glasses that are going to be used. In the test, we used the Oculus Rift, and we found out that it's a little bit limiting because you have to sit down, so we used HTC Vive instead. And also, instead of using augmented reality on desktop, we used it on mobile phone, so it's much more easier. In the baseline experiment, we created a benchmark where we gave the same task that we will use in the service prototyping experiment, but for without any kind of help, without any kind of service prototype. And we looked at how long will they take to finish this, complete the task, and how many errors will they have, and how many questions will they have. Looking at the service prototyping experience, service prototyping experiment, the volunteer comes to the lab. We had conducted this experiment at Laval, at Angers, and at Fort Wangen as well. So at these 3 places, the participant volunteered for the experiment. They came, they had a brief discussion about the experiment. We had also videos and PDFs that they looked at, so to introduce the experiment. And then they proceeded by filling out their information in the demographic survey, and then started by using one of the service prototypes, and then filling out, completing the task of work, and then filling out the bipolar survey, and then doing this simultaneously until they finish, and then it's finished. So this bipolar survey has qualitative and quantitative elements. So quantitative elements, as it's a bipolar survey, and the qualitative elements are justification elements to each question. So after each bipolar question, the participant had to fill out why did they choose this rating. So the ratings were from -2 to +2, and the participants had to show why they choose this rating. So looking at the results of the experiment, as we can see here from the 2 pictures, on the right side we have the task being done. So in the baseline experiment, we could observe that the participants actually were very negative. They were really not happy because they don't have any kind of help. And a lot of the comments were, I cannot visualize it, I cannot see the start. And you can see this from the observations performance, that the average completion duration was actually 11 minutes and 9 seconds. So this is to disassemble the task and then assemble it. And the participants had 4.3 error on average per participant. So almost 90% of the participants have committed one or more errors. So that means that we had 30 participants in the baseline experiment. So that means that only 3 participants were able to complete the tasks without any mistakes. On the question side, or on the explanation request side, the participant also had a 4.33 average explanation request per participant. So they asked more than 4 questions per participant on average, and 93% of them asked questions. So even only 2 participants finished the task without asking any questions. Comparing the of course, to look at the baseline experiment, we didn't have a survey after the baseline experiment, but we asked them several questions. We asked them what are the challenges that they faced, what are the biggest challenges that they faced in completing the task. And the participants said, most of them said that they couldn't visualize the start, or they couldn't visualize the end. They didn't know where to start, they didn't know where to end, they didn't know which position to put, they didn't know which order to put. And even some participants had issues with details of the metal part, that the metal part is heavy, it's around 10 kilograms, but nowhere to be found that it's written that it's 10 kilograms. So when they tried to carry it, they might have injured themselves because they didn't know the details of this metal part. And the second question was what kind of recommendation they might give for someone that will embark on completing the task. And the answer were ranging from giving them some kind of video demonstration, even a hands-free guide, some kind of instructional step-by-step guide, some kind of training, but all of them said we need anything, it's better than nothing. Looking at the performance results, and we can see that the baseline experiment in the gray, and after that the paper-based, mock-up-based, virtual reality-based, augmented reality-based, and the mixed reality-based. Looking at the paper-based one, it was the least efficient in terms of duration. So it took around 7 minutes and 15 seconds on average, which compared also to the baseline experiment, still less than the baseline experiment, but still much higher than the other service prototyping forms. What was very interesting to see is that only 6% of the participants that used paper-based service prototypes had errors, which was actually the least amount of participants after the mixed reality. Looking at the mock-up based service prototype, it was quite efficient compared to the paper-based, but at the same time, 11% of the participants actually made errors. And that might be to the fact that they had to watch the videos of the disassembly and then made the task. And some of the comments were that they forgot about the steps. In the case of virtual reality service prototype, we can see that it was quite efficient compared to baseline experiment, but actually it was not as efficient as the mock-up based. But this is due to the fact that the participants had to wear the virtual reality glasses, be inside the virtual reality world, experience the virtual reality simulation, and then go out of it and then physically complete the task. And we can see that it had the higher error intensity. That means that the maximum amount of errors committed by one participant was 3 errors. At the augmented reality-based service prototypes, you can see that it's the second most efficient in terms of task completion duration after the mixed reality-based one. But we can see at the same time that 20% or almost 20% of the participants that used augmented reality service prototypes required further explanation. So they asked questions, which was pretty surprising because it was self-explanatory with the augmented reality. But by looking at the mixed reality service prototype, you can see that that was the most efficient, it was the most effective, and it had the least amount of errors and explanation requests as well. So this is a summary of the performance results that we have. Looking at the ratings that the participants rated the different UX properties that we have in the survey, we can see here the 5 different curves of the 5 different service prototyping forms. And as you can see, the gray is the paper-based, green is the mock-up based, blue is the virtual reality-based, orange is the augmented reality-based, and the red is the mixed reality-based. And we can see that in the part of interactivity, the immersive service prototypes, the 3 immersive ones, were rated much, much higher than the conventional ones. One that's to be expected because the interactivity of immersive devices is much higher than the conventional ones. But as well as the emotional engagement, which was actually expected that we have similar ratings for all of them, the participants rated the emotional engagement of the immersive forms higher than the conventional forms. And in the case also of the cognitive engagement, and this was expected because cognitively immersive technologies use the mind function and brain functions to create this 3D effect, to fool the senses into thinking that we are somewhere else. So cognitively, we are much more engaged when we are using these devices than we are using the conventional ones. Looking at the attentive, we can see very interesting point that all the forms except virtual reality had almost the same rating in the attentiveness. So that means that the participants felt that they were most attentive while they are using virtual reality. This could be due to the fact that they were wearing glasses that covered their eyes and they were totally encapsulated in this virtual world. And looking at the friendliness property, also, immersive service prototypes ranked much higher than the conventional ones. As you can see, the mixed reality topped ranked highest, and then the augmented reality one. And then we can see that the readiness to recommend also rated much higher for the immersive ones. But actually, the mock-up service prototype was very close to the virtual one. So that means that the mock-up based had a relatively high rating in the intention to adopt. So compounding these results together of these UX properties, as shown before in the research model, we can see that the ratings of immersiveness, for instance, is much higher when we look at the mixed reality based service prototypes. So the participants rated the mixed reality based service prototypes as the highest immersiveness, which was actually very interesting because by using virtual reality or encapsulated, so thinking about it, I thought that virtual reality will have the highest immersiveness, but the participants gave mixed reality a higher rating for immersiveness. But the participants gave the highest real-world association rating for virtual reality service prototype, which was expected, as you are totally disassociated. If you are wearing the glasses, if you are wearing the head-mounted display, you are in a different world, so you're disassociated with the real world. And for the mixed reality, it also was rated as the highest prototype effectiveness, the highest experience, and the participants also rated it as the highest intention to adopt. So they had the most intention to adopt for the mixed reality based service prototype. So as mentioned before, for each of the UX questions that we had, the 15 questions in the bipolar survey, we had justification elements. And these justification elements, the participants filled in text form. Why did they fill in the specific rating? So what I did was the state took this free text form that the participants filled in their survey and created a sentiment coding. Sentiment coding meaning that I looked at the comment and I said, okay, if this a positive comment, then we have +1. If it's a negative comment, it's -1. And if it's a neutral comment, it's 0. So I created a code to be able to see how does the sentiment match the ratings that they give. And as you can see here, we have the green color is for positive, orange is for neutral, and red is for negative. And you can see that it's almost identical if we look at the sentiment and the UX rating that the participant gave. So we have a identification of the sentiment in the UX ratings. So the first major output of the study is that we allowed service designers to understand more about the impact that the different forms will have on the attributes. The attributes basically are the main blocks of creating a service prototype. So a fidelity means that how much functionality will be built in a prototype. Resolution is how much will the prototype resemble the final design. Effort means that how much organizational effort and resources will be put into the service prototype. Interactivity is the interactivity degree of such prototype, so the level of interactivity. And last but not least, the user experience, meaning the stakeholders' experience of such prototype. So looking at the prototypes, looking at the paper-based service prototype, we can see that it has low effort, meaning that if you're looking to create a prototype with a low effort, then your best option would be paper-based. So it's the most appropriate because you will exert the least amount of effort, but at the same time, you will have the least amount of fidelity, the least amount of resolution, the least amount of interactivity, and the least amount of user experience as well. If you're looking at a higher abstraction of an idea and you want to create some kind of depiction or a representation of this idea, you can use a mock-up based service prototype, whether it's physical, whether it's digital, video-based. It allows us to create a middle point of interactivity, a middle point of fidelity and a user experience. And it's appropriate for after the ideation phase. Looking at the virtual reality-based service prototype, it enables us to have the highest resolution in the prototype, as it allows us to simulate any kind of environment, any kind of service environment, any kind of service artifacts. So we'll be able to have an exact depiction of how the service would look like at the end. And it allows us also to interact with all these environments and all these artifacts. So it has the highest interactivity degree as well. Augmented reality, on the other hand, allows us to have a high fidelity, high resolution. Of course, it will have high effort, but it has a less interactivity and less resolution than the virtual reality as well. Looking at the mixed reality service prototype, it enables us to have a very high fidelity, to have the functionality that we could have in the future service, and has the highest also user experience. So it allows us to have a very near user experience to the service experience that will be at the end. So we were able also to deduce benefits and drawbacks of using immersive technologies on service prototypes. So looking at that, using immersive technologies in the service prototyping process increased the effectiveness of the service prototyping stakeholders, and they were more efficient in completing their tasks. And while they were more effective and more efficient, they were also had a more satisfying experience. So that means that the service prototyping experience itself was more satisfying than the conventional experience, which enabled them to understand more the idea, to understand more the context of the service, which also shows that it had a higher degree of adoption. So they were open to accepting and adopting such prototypes forms due to the increased effectiveness, efficiency, and the improved experience. In case of, for example, virtual reality, we can have a risk-free training, because imagine if you want to train pilots with real planes, who knows, every day we have 2-3 pilots that will not be there anymore, because training with real objects is pretty risky, especially in such fields. So using virtual reality for risk-free training and learning is very important as well. Which also gets us to the last point. It makes it easier to understand, because you go out from the language barrier, the location barrier. You could be anywhere in the world. You could speak any language in the world, and I could put you in a virtual reality simulation, and you would be able to understand, or give you a mixed reality hologram sequence, and you'll be able to carry on and understand each step. Looking at the drawbacks of using immersive technologies on service prototyping, few occurrences of cyber sickness occurred, which might have impeded the service prototyping process. Cyber sickness is similar to boat sickness. If you are ever in a boat and you just get a queasy stomach and you don't feel well, and this happens for some people when they are wearing head-mounted displays. I think also the first time I tried virtual reality, maybe in 2013, I also had like a couple of cyber sickness occurrences because the head-mounted displays at that time, they had low latency and frame rate also was very bad. So I could only hold 15 minutes or so, but now with the new devices, sometimes I can go several hours wearing the devices without any kind of cyber sickness. These devices also cost money, so you have to buy the devices, you have to buy the software, you have to train employees, you have to train people to learn how to develop these set simulation environments, visualization, at the same time also to pay for all these devices. And also you have to learn how to develop these simulations. You have to develop these visualization. You have to adapt to it. So there is a learning process and a learning cost to it. And if you are want to introduce it in your company, definitely the higher ups will always ask, okay, how much money am I going to save through this use, or how much money am I going to make? And sometimes it's very hard to evidence the benefit cost ratio in the start. So these are the drawbacks that we deducted for the implementation of immersive technologies on service prototyping. We categorize these impacts into 7 different impacts. These impacts show us the positive and the negative impacts that immersive technologies have on service prototyping. So looking at the exploration impacts, we have like risk-free training, the improved learning process, but at the same time we have this higher initial effort. We have also reduced time spent and better performance. These are the efficiency impacts, but at the same time, the complexity of the design is increased. We have the effectiveness impacts. We have also the experience impacts, which makes it easier to learn, more satisfying experience. We have these physical impacts like the cyber sickness and the ability to have a risk-free training or injury-free training, and also a barrier-free simulation, so without any language or location. And looking at the psychological impacts, where we have a happier participant, higher acceptance, and of course the monetary impact, where we have the higher initial investment and this higher usefulness of a prototype. To summarize the results, looking at the paper-based service prototype, we can see that it was useful. The participants liked it the least from all the service prototypes, but they rated the usefulness property with neutral. It had the lowest experience ratings, the lowest intention to adopt rating, and the lowest rating overall from all the other prototype forms. Looking at the mock-up based one, it was easy to replicate, easy to understand as well, but it delivered a neutral experience. So the participants were uninterested. They were not excited to use it. So the experience there was more or less neutral. Looking at the virtual reality based one, virtual reality allowed the stakeholders here to enjoy freely within the virtual reality world. And this was from the verbal comments that I had after the experiments, that they enjoyed it so much, especially the participants that tried virtual reality for the first time. At the same time, there were some participants that had cyber sickness, and it might have been impeding their understanding of the task and their experiment as well. Looking at the augmented reality based one, it was quite efficient looking at the task completion duration after the mixed reality one. But we could see that prior augmented reality knowledge is actually a positive thing here, because 20% or less than 20% of the participants that used augmented reality based service prototype asked further questions while they were using it, which was pretty surprising as well. Looking at the mixed reality based one, it was the most efficient, the most effective. It had the highest immersiveness and the highest service prototyping experience rating, and it had even fewer cyber sickness occurs. There was few, but it's still fewer than the virtual reality based one. To summarize the impacts of immersive technology, we can see that immersive technologies takes you from learning by doing to learning by experience. To have this risk-free experience, to learn and to understand ideas in a totally free, language-free, barrier-free environment is the biggest impact that we have from immersive technologies, especially when we are talking about virtual reality, because virtual reality, you are encapsulated in a virtual world where you have the ability to have risk-free training. But we have to say that several participants suffered from cyber sickness, which might be due to the fact that they are fully immersed inside and they were just panicking, or their brain wasn't not accepting it, that they are encapsulated in this virtual world. Looking at the augmented reality-based service prototype, it was relatively efficient and convenient because you can use it with your personal devices like mobile phones, like tablets. But as we said, some sort of previous background knowledge is a plus here, because 20%, almost 20% of the participants that used it asked further questions. And if we look at the mixed reality-based one, it allowed the participants to have a hands-free experiment. Because their hands were free, they were much more freer in creating their experiment, and they had also fewer cases of cyber sickness as well. So what kind of limitations did we have in the study? So the study was conducted, as I said, in the Arts-et-Métiers campus in Laval, in Angers, and the Furtwangen University campus in Furtwangen. So it was conducted in academic context because it was on volunteer basis. So we had almost around 67% or 70% students and the rest non-students. So that means that it might have been different results if we had people from the industry, but of course that would have cost much more time and also costs, because 100 participants from the industry, that would be a definitely higher cost than attracting 100 volunteers on free basis. The complete number of participants was 133 participants. This can be also construed as a limitation. Of course, 1,000 participants would have been much better, but in the time span of only 3 years, 100 and an experiment duration of 1 hour, so that means around 133 hours of only experimentation without data analysis, data display, representation, and all the things. So that means if we wanted to make it for 1,000 participants, it would have taken maybe 5 to 6 years of continuous work, and maybe other campuses that I had to visit. Also, the survey was also created in 3 languages. It was first created in English and then created, translated into German and translated into French to be used in the different campuses. Also, there was limitation the uses of the technologies, as we saw that cyber sickness impeded the use of or the completion of the experiment for some participants. And also we saw that the previous immersive technologies experience was also some kind of limitation for some participants. So to conclude, we have validated the research model, statistically validated it, and we confirmed all the hypotheses from hypothesis 1 to hypothesis 5. We also had reached a characterization of these service prototyping forms and allowed to have a selection in regards to the purpose and attributes. So for each purpose, you can select a different kinds of form, and for each attribute that you need, you can select a different type of form, which will help other researchers, other service designers to inspire themselves from looking at these categorizations to use the best form possible for their, according to their purpose and according to the attribute. And we deducted that combining multiple SP forms, so combining conventional service prototypes and immersive service prototypes, might be actually the most optimal solution to create a service. So that means that we use conventional service prototypes in the early stage of development, and depending on the complexity and interactivity of the service idea, so the lower the complexity, the lower the interactivity, the higher probability we'd be using a conventional service prototype form. And we will use the immersive service prototype form, which is more appropriate for later stages of service development. It's also more suitable for complex and multidimensional services. So multidimensional services are services that have more than one dimension. So you have the artifacts, all the artifacts that might be in the service. You have the environment that the service takes place. You have the process of the service. You have the actors, so the stakeholders of the service, and you have even the data if you're talking about smart services. So talking about smart services, I'm currently working in the Smart Services Competence Center in Fort-Wayne. My role is to help companies in the region understand how to create smart services by using immersive service prototyping and by using service prototyping. I'm currently investigating several industrial projects or several industrial project proposals, and currently also looking forward to studying different service prototyping descriptive models, looking at the data model, looking at the environment model, looking at the actors model, and looking at each of these models as a standalone model and investigating them as well. So throughout the 4 years throughout the past couple of years of this dissertation, I was privileged enough to be in part of several publications. I was author of one international journal, which was published in 2019. I was also part of 10 international conference papers, 7 of them as a first author, and also a part of 3 book chapters, one of them as a first author. So, thank you so much for your attention, and I hope you learned something new today. Here, if you can see the barcode on the right side, you can find my ResearchGate profile with all my publication, and on the left side, you can find my LinkedIn profile if you want to connect. Thank you very much.
Thank you very much, Abdul Rahman, for this inspiring presentation, which also matches the expected duration. Thank you.
Perfect.
And now we will switch to the second part of this defense, which consists for you in exchanges views with each of the jury members in turn. And so we will start with Professor Kurwant Pawar, who will give us his comments, and also he will ask a few questions, and so you will discuss on your whole work. So now, please, Professor Pawar.
Okay. Thank you very much, Madam Stephanie Bouzenet, and President, and all the jury, and including Simon Richer, for the invitation. I'm delighted to be here. And again, good morning to Abdul Razek.
Good morning.
I really enjoyed the presentation. It's an excellent presentation. And also, I read the dissertation, and it is a very, very good piece of work. And as they always say, throughout any kind of defense, I should be able to learn something new. And I have indeed learned something new from this dissertation and your presentation this morning. So in that respect, I think I'm very grateful to everyone for this opportunity to be here today. I think the main of prototyping, as you have mentioned in your presentation, has been around for decades. And I myself, as an engineer, have worked in design for a long, long time. And during the 90s, a so-called concurrent engineering was a very sort of highly used phrase, and no one knew exactly what it meant. And within that concurrent engineering, the role of prototyping has been extremely important. Because, as you mentioned, if you are designing a new product or service, and before you put it into practice, to launch it to the market, you want to understand all the different parameters and different challenges it may face during the actual practice. And in that respect, the role of prototyping is extremely important. Another important issue is time to market. Because in whatever we do, we want to develop a new product or a new service and introduce it to the market as soon as possible. And that also implies time and cost. And cost, of course, is another big factor in trying to use some kind of prototype in order to reduce time to market. And also, you mentioned about the failures. And we want to avoid failures in practice, which, as you mentioned, give an example of you're flying a new plane and you want to do all the simulation and learn in training so that there are no failures in practice, which can be obviously devastating to all of us. And that also leads on to training. In our training, we want to be able to train our workforce and learn from experimenting during the course of doing prototypes. And the whole domain of service aspect is relatively new to all of us. And service, again, as you mentioned, is intangible. Sometimes you can't touch and feel the service. And so therefore, designing a new service isn't perhaps more challenging than a product. And that basically comes down to, I think, so in that respect, I thoroughly enjoyed your work, and it's a very, very forward-thinking study which you have done. I recognize the limitations of the study in terms of it's laboratory-based. It is a controlled experiment which you have conducted, which is fine. If I just turn to the actual, what I take away from this study, if I say look forward the next 10 years' time or 20 years' time, what are the key things? Now put it on as sort of 2 or 3 areas which you think what you have contributed, which we didn't know before. That's what PhD is all about. What new knowledge have you added to the existing body of knowledge? And just summarize those in very briefly. What are they?
So the existing knowledge that I added, the new knowledge that I added to the existing ones. First, before this study, there weren't any kind of empirical study that compared these different service prototyping types. So the other authors were always comparing the normal process with one prototype type. And there were also no definition of the service prototyping experience, which was very important to combine the user experience field with the service prototyping one, as it's a new research field. I also think that a very important addition was the introduction of asking what companies think about service prototyping. Throughout my first project and throughout the dissertation, I had the privilege of visiting several companies. One of them was a company called Leaphair. And this company, I shared the results of the experiment, the results of the research. Throughout the 3 years, I had a couple of workshops there. And in the last workshop, I found out that they actually employed a new employee for service prototyping and another employee for immersive technologies, because they saw the added value of using immersive technologies in service prototyping. I was also in contact with a lot of authors in service prototyping, especially Johan Blomqvist, which I inspired a lot from his work. And I saw that the connection between immersive technologies and service prototyping wasn't there. And I think one of the most important points that I had is that I connected these bubbles or domains together, that there wasn't any connection to them before.
Yeah, but what is the actual knowledge bit? What's the knowledge part which you feel, if you use written papers, written journal papers, written conference papers, if I say somebody wants to cite you they cite you in their paper they're writing. What is the unique thing would they cite about this research?
Yeah, they can cite the multidimensional service prototype definition that I had in a paper in 2017, because there wasn't any multidimensional service prototyping definitions. There were several definitions, but none of them included all these dimensions and included the experience of the service prototyping. They could cite my service prototyping experience definition 2018, as there wasn't any definition for the experience of prototyping. They could also look at the comparison that I did and the categorization I did of the different service prototyping forms. And before that, there wasn't any research on this categorization. So the term conventional service prototype and the term immersive service prototype are both brand new, as well as the term service prototype experience. And of course, the empirical study itself, the researchers could look at it and could see, because there wasn't any research before that compared these 5 different prototypes together, and they could look at what kind of impacts, because this was also not mentioned in the literature before, the impacts of immersive technologies have on service prototyping.
So it's a definition, comparison, and then I think the immersive service prototyping and impact.
Exactly.
What about the methodology?
The methodology of the prototyping itself?
Yeah, because the experiment you have done, the uniqueness of the methodology which you have used, is there any new knowledge which you have added?
Yes, this is also came with the definition of the multidimensional service prototyping definition in 2017, where we went from a linear process that was always the thinking about prototyping or service prototyping before, that they had a linear process, and went into an iterative circular process. We start from an idea and we go to a representation of this idea. We create a perception or an experience that creates a perception, and this perception creates a reaction, and we go back to the idea and we have a continuous improvement cycle. Before that, the process was that they move linear, they finish one prototype and they look what they could improve, and then they go back.
Yeah, I think that would be an important contribution, which I think which you have made, which perhaps previously wasn't done. On the other hand, there are limitations which you have highlighted. And I think there is a laboratory-based experiment which you have done. At the same time, you have held workshops. And the limitations are also about perception, is how the participants feel, which is very difficult to comprehend. And it is how I feel about my experience. And that I think is also a big limitation. And you mentioned in your presentation and your dissertation that they're all volunteers, they're students who participate in the experiments. I think 70%, I think you mentioned, were students, volunteers. And that means age category. If you give it to somebody like me, who is not a student and who is a more senior citizen, and my experience will be totally different. Do you have any comments on this at all?
Of course, the other 30% that we have were mostly professors and other PhD colleagues or other colleagues that works in the University of Furtwangen or worked at the Arts et Métiers, Laval or Angers campuses. And actually, the age difference wasn't apparent at all in looking at the different ones, except in the virtual reality ones. In the virtual reality one, there is a big difference between under 35 years old and over 35 years old. But in the other forms, especially in the mixed reality one and the augmented reality one, there were almost no difference. But actually in the paper one, I could say also there was a bit of a difference, that the older age or the more experienced the participant had a better experience with the paper than the younger students. They were, from the comments, the younger students were like, oh, I have to read one paper. Oh, it's a lot of text. oh, I have to watch a 1.5-minute video. So that was the comments that I got from the younger participants, while at the other hand, the comments that I got from the more experienced participants were more about the depths of the process, about the model, about how it works, and they were really interested in how it works. Also, I have to say, some of the more experienced participants faced cyber sickness. These were the most people that faced cyber sickness where they were using virtual reality.
So I think that was most sort of interesting, I think, a dissection of your findings. You could have said, okay, you looked at all this, and the age of the participants, and these were the factors which actually were distinguishing for the, say, over 35s or under 35s.
Yes.
And similarly, gender. Was there any differences with the gender at all? No.
Yeah, yes, there were several differences in each of them. If I may, I could show you the presentations the slides that I already made. I had more than 40 slides extra, and most of them for the genders. I can show it to you quickly.
Just one slide, please.
Yes, or I can explain them verbally. It's not a problem at all.
I think I'll just explain it, please.
Yeah. Yes, in each form there were differences in the genders. Looking at between female and male, we found out that the male had a better performance, for instance, in using paper prototypes and for using also virtual reality prototypes, and in the using of mixed reality and augmented reality, they were almost same performance. On the other hand, in the mock-up-based service prototypes, the females had a better performance than the males did. And also I did a comparison on the professionals and the students, which also showed that the professionals had a better performance in the conventional forms, which is the paper-based and the mock-up-based, and the student had a better performance in the virtual reality and the augmented reality, but both had almost the same performance in the mixed reality-based one.
I think it would be useful, I think, to have one small section at the end,
yes,
future research directions, because you mentioned limitations and saying these are the possible limitations. Based on limitation, these are what one should be doing in future. So the future researchers can say, okay, yes, Abdul Razek has done this, however, he didn't do this. And this would be useful to study in future. So I think in that case, you mentioned, this is a very much exploratory baseline research which you have conducted.
Exactly.
That means the potential scenarios for doing other work from this study are very, very high. So therefore, that would be very useful to have, saying, just half a page saying, these are the future directions which students can take for their further studies and further experiments. Just one final comment, if I have the time. We're all facing this COVID crisis around the world. If you had to design an experiment, how we should handle this through service prototyping, how would you go about doing it? Because we all face at the moment, for example, my university is facing problem. Students are in difficulty. They're under lockdown situation, isolating themselves. We found some cases of positive cases on campus. As planners or decision makers, and we want to be able to plan our new service, how would you use this kind of approach so that the service we provide is almost perfect?
So to create an almost perfect service that will accommodate for the current situation of COVID, that we are almost all staying at home and the infection rates are going up at the moment in Europe, as well as where I am in France and in Germany and in England. I think that using devices like this one, I don't know if you can see it from the background, this is a virtual reality head-mounted display where and you can have an inexpensive a head-mounted display from a couple of euros to this one. It's a bit more expensive. This is only 100 euros, and you can use your mobile phone directly to be able to see this virtual reality simulation. And I think that virtual reality is one of the technologies that we have to use the most while we are in this situation, because it allows us to be at the same time in a safe place at home or in our safe space, and at the same time meet other people, sit in the classroom, have even a conference, Laval Virtual this year, thanks to Simon, was made also in a virtual reality world, which was, I think it was the first conference to be made in virtual reality, and it had over 11,000 participants. And I think everyone that participated in the conference, which I had discussions with, was very happy that they even had to meet someone, even if it's not real, because this virtual meeting, even if we are not co-located in the same place, it gives us a bit of this personal meeting that we have in the normal life. So I think using immersive technologies to leverage this experience, to use devices like mixed reality, augmented reality, especially virtual reality for the classes, would be the most optimal solution and the most appropriate one for our current situation with COVID.
Okay, thank you very much. Perhaps all to finish here because our time is short.
Yeah,
I hand you
thank you
back
so
over
much.
to Stephanie. Thank you very much.
Thank you so much.
Thank you, Professor Power, for that rich exchange. And now we will listen to Debbie Monticolo, to Professor Debbie Monticolo, his comments, his questions, and of course we will listen to your answers, Abdul Rahman. So, Debbie.
Thank you, Madam President. First of all, thank you for the invitation. Thank you for the jury member, Simon, Mark, Laurent, to invite me to review this PhD thesis. Thank you, Abdel Rahman, for your presentation. It was very clear. So this morning I was secretly expected that what would be the PhD presentation, because you work on immersive environment, and I was really expected that we had an immersive environment in the PhD presentation, but it's I know it's really difficult to do it. So, but your PhD was very interesting, and you integrate some videos. So I have more. When we read the manuscript, we don't see exactly what happened with the experiment, and this morning I have seen more picture and more video, so I can really realize what you did. Thank you very much for this, your manuscript. It was very interesting to read, and you have made a very big work. So it's a big manuscript for me to read all of this. I work in a research laboratory dedicated to innovation. So prototyping is very important for us, because in innovation we like to have prototype to try to experiment things before to have an innovation on the market. So this subject is very interesting for me. So if the subject is very interesting for me, I have many questions to ask you. I try to find my list of questions. So first of all, you have made a very big, an important work about the state of the art, and you have exposed all the definitions that we didn't add in the literature, and thank you for that. And you also have tried to define all the key indicators, the key factor that could be useful for you to measure the impact of using an immersive technologies in service prototyping. My first question is how you use all these key factors and key indicators to build your research model and to build your experiment.
So I looked at the different research that was conducted before me, and I looked at similar researches in the user experience, immersive technologies, because there wasn't any research that combined all these three together, the user experience part, the immersive technologies, and service prototyping. So it was a first study, so no one before did it, so there was no standard to follow. So I tried to look at what the research in these three fields are doing and try to find what concurrently all of them are doing it and combine them all together to have a more understandable model and process. And also I try to have always contact with the industry to not only talk academically, but to talk academically and industrial approved, to say it like it could be applied directly in the industry without further work, let's say.
Okay, thank you. And like you said in your presentation, service prototyping can be used in many engineering fields. And all the engineering fields have a specific process. For example, if I work in computer science, we use specific process. In mechanical design, we use specific processes. And I wonder how this engineering process influence the way that you have designed the experiment and the way that you have build your research experiment model.
Of course, we looked at service engineering, service design, and service innovation, and we tried to place our experiment to have elements of all of them. We looked at the service engineering part. There was this linear prototyping process that was discussed firstly in the service engineering, which says that to create a prototype, they start by idea. They go after that to the requirement process. They create a design, and after the design, they create an implementation, and then you have market release. But what we found lacking here is that if we are in the middle, so imagine you are in the design, and then you find out that one or two of the requirements that you have in the design are not working anymore. So that means normally you would have to go back to the idea and start all over. What we did in service prototyping is that we took this idea, but we said, okay, we'll take elements of service design, which has this concurrent iterative process, and create this process and bend it to be iterative. So that means if we find ourselves in design and we have to change an idea in the design, we just change the idea and then we go back to it. So we have this iterative process, but at the same time flexible. So it's not like we have to go through the whole step by step. No, we can jump back and forth, and it's much more flexible, because we found out that this is much easier in reality when you're sitting with stakeholders to create a service, especially in a company. It's not like, now we have to cut our papers and throw them away and start again. No, we just, okay, we regroup, we make another brainstorming session, and we continue from where we stopped.
Okay. In slide 8, you have your research domain. Yes, show me again, please, if you can.
Yes, of course.
There is another one where you show, sorry, slide 15. Slide 8 was the question before.
This one.
Yeah. So you talk here about, you said you want to take also into account of the effectiveness of your approach, and how you can make the link between the engineering process and the effectiveness of the engineering process and the effectiveness of the service prototyping.
Yes, in 2016, when we started the Dimension project, we made a survey to ask companies in Germany about how they create their processes. From another survey, we found out that 60% of the companies that use the traditional method of creating a service, they fail within the first year. So that means that they have 60% failure rate within the first year. And by using service prototyping, it eliminates this failure process, because you have this iteration circle, this from idea, presentation, until you have the best idea possible. And you always sit with other stakeholders. So you sit with the customer, you sit with the service designer. So that means that everyone is involved. So at the end of the process, everyone is happy. And at the same time, we have the best possible idea and the best possible service.
Okay. You use in your research work to use a statistical methodology to validate your model. And did at the beginning you define the number of statistical results you need to validate it? I mean, did you take the time to say that maybe I only had 133 participants and 100 set of data, I guess?
Yes, yes.
Is it really enough in a statistical point of view?
Yeah, that's why.
Model?
Yes, that's why we had this limitation that the numbers of the participants were 133. Of course, when we have 1,000 participants, that would be a much better result and will give us a much deeper understanding of the problem. But at the same time, I had only 3 years to finish the dissertation, and at the same time, I had to define all these definitions and create all these models, and at the same time travel between Germany and France for the experiments. So it was very challenging or almost impossible to make 1,000 people in only 3 years.
Okay. My question was more about the statistical point of view, number of questions you have and the number of results you expected, and is it relevant if you do a statistical test, or you need more?
No, I chose that we have 15 questions in the survey, and we validated the relationships in the question. I can get also a slide to show. I had created many slides for the presentation, but I left them outside for further clarification. So if we look even on the model statistical evaluation, we can see that they were all, the effects was all confirmed, but the most positive direction was this direction from the effectiveness to intention to adopt. So the more effective the prototype, the higher the experience, and the causality effect would be the higher the intention to use.
Okay. Okay. The other question is about the profile of the participant. You said before that they are all over 25 years old, but I wonder if do you think there is a difference between if you take a participant from a professional field? I mean, if you go in a company and you work only with mechanical engineer or mechanical technician, it will be a different result because they have already expert on their domain. Or is it not significant that to be expert or not expert for this kind of experiment?
Excellent question, because it definitely makes a big difference, because I had several participants from the industry. Some of my friends that work in technical fields came and supported me by doing the experiment at the university, and they finished it in record times. One of my friends is working as a mechanical monteur here in a company, and he finished the disassembly in 45 seconds and the assembly in 42 seconds. So much faster than the normal, and he didn't have one question and he didn't have one error. So that means that the knowledge definitely makes a big difference, and even the knowledge of the students makes a big difference. If we looked at the different results of Angers, where it's a more engineering campus based, and Laval, which is more technology based, and Furtwangen, which is more IT engineering based, it was different than each other. I think the...
So, sorry, it seemed David had an issue with the connections, so he tried to join us. He's back.
Okay, I'm very sorry. Lost
no worries.
It's not because your answer was not.
Okay.
Okay. So my next question is, I really appreciate at the end of your manuscript you have a big section about discussion, and you take time to expose the limitation of your research, and you take time to make some recommendation how we can use this kind of approach in industrial project. And I just wonder, what is missing for you to really adapt your recommendation directly to the industrial field? Because for the moment, your recommendation was inside the discussion. And if tomorrow you have to work with industrial project or inside industrial project, what will you do?
So if I'm starting tomorrow to work with industrial product with service prototyping, I will be using firstly the workshop format to sit with the stakeholders of the companies, to talk with them about their needs. What kind of service do they want to they create to sell? And then we sit together and we have a brainstorming session, and we take the service prototyping process from the start by using multiple service prototyping forms. So by using, maybe in the brainstorming session, like I did with this company Leap Hair, I had a Lego series play session where I had 8 hours where I went to the company with their whole service division. We sat with Lego blocks, and we created 2 new solutions for their service problems that they have. At the start, actually, they were laughing when I got a bag of Lego blocks. But after 6 or 7 hours, they didn't want to go out of the room to leave their Lego blocks. They were so into creating their own service ideas with their own hands, and to visualize their idea into something that, instead of intangible, like a PowerPoint presentation, into something tangible that they can have in their hands. And I think the next step would have to be using immersive technologies to explore the idea from inside.
Okay. Okay, thank you. Last question. I work in digital innovation field, and the user experience is very important for us. And when we design a new digital device, we really take into account about how the people work or what kind of digital device they will use tomorrow. And in your study, you have a lot of feedback during the experiment. But do you think it would be interesting to also have had some element about user experience outside your experiment, but the way they can use a new digital device, for example?
Yeah, I think it would have been very interesting to have this, but as I said before, the time of the dissertation was limited, and at the same time I had 1 hour that was fixed in the test of the experiment, that only 1 hour is the most optimal time. It's the maximum time I could have with one participant without them feeling like, oh, okay, now I have to do this again, I have to fill this again. So I thought, okay, if I put too much element in the experiment, the volunteer, the participant might feel overloaded, and at the end it might degrade the whole performance. But I think it might have been very interesting to look at elements outside of that.
Oh, it's a things to do if we would like to have a longer perspective point of view. Okay.
Exactly.
Okay, thank you very much.
Thank you very much.
Thank you.
You finished for me.
Yes, thank you, Professor Monticolo. So now we will give the floor to Dr. Laurent Dupont, one of the examiners of this PhD. Yes, Laurent.
Thank you very much. So thank you, Madame la Présidente. Thank you, Simon and Marc, to give me the opportunity to follow this PhD. In fact, I met Abdul I think 5 years ago, in 2016 at ICE conference, we met us in a scientific conference, and I'm very, very happy to be here today because we meet us several times in Laval or other cities in Europe, and each time we get the opportunity to exchange and to work together. So it's a nice moment, and I'm very happy to be here. To talk about the PhD and your defenses, I think it's a very big work, and as David said, it's a big manuscript. There are a lot of elements, in particular for the first section, so second section, the state of the art, and it's very, very interesting to see how you try to catch all the definitions and try to understand all the aspects of your topic. So it's very, very interesting to follow you in your manuscript. So I have also several questions as a scientific manager of a research platform dedicated to prototyping and also some immersive technologies. But the first question is about the state of the art, because you used Google Scholar as a database to find articles or different definitions. But what did you use this database? Because when I compare with Scopus, in fact, there are less papers. And we can see the last few years, the peak coming from your own publications. So why did you choose to use a broad database with not only scientific paper and not Scopus or Web of Science, for example?
I wanted to not limit myself to only a specific amount of papers. I wanted to see what is there outside, even outside of my field, because I wanted to see if the terms that I used, which is like service prototype experience, conventional service prototype, or immersive service prototype, if they were mentioned anywhere, if somebody in a special magazine, in a marketing magazine, in a service magazine, if they were mentioned, because I wanted to know if somebody was thinking about what I was thinking about, and it was thinking the same thing, that it was missing, it was lacking. So that's why I used the broader the Google Scholar search to have a broader look on what is out there, to have a better scope, to be able to fix these domains. As you mentioned from my literature review, I try to have as much as extensive as possible for all the definitions and go through all the definitions that are mentioned in the literature to have a better understanding of the whole topic in general.
Okay, so I think it would be interesting to also to show us what are the visions by the scientific committee, for example, and by the industrials or other communities, because that could help us or help you to try to find a way to spread your research and to adopt the good vocabulary for one kind of community, for example. But I think it's very interesting to have these broad visions, because that help us to see there are many definitions, and it's important to find a shared knowledge.
Yes.
You explain in your manuscript, and you talk about this point in the limitations. You explain you used English, French, and German surveys for your research. And you also show that can be an issue, in particular for the question 11, because you decided to delete these questions in your analysis. So have you imagined, or can you imagine or describe a possible way to use bipolar survey with different languages? Do you find some solutions if you need to start again your survey in several countries with many different kind of people?
Yes, it's actually one of the main issues that I had with this question is that the understanding of the question in the 3 different languages might be different. So I'm not native German and I'm not native French speaker, not even English speaker, but I speak English and German. I found out that there are some stuff that are just lost in translation, like we say. And I think the recommendation I could give myself if I went back 3 years in the past, if I had a time machine, is to make the question much more clearer, much more easy, much more simple. So when we translate them from English to German and from English to French, and we translate the answers back from French to English and from German to English, they would be much more compliant than we had now. And the bigger issue is also when we had this justification areas, each of the participants filled in with their language. So the German people filled it in German, the French-speaking people filled it in French, and the other English-speaking, they filled it in English. So I had to also translate all the justifications back into English, and sometimes they didn't make any sense. I had to ask someone who was native French or ask someone who's native German to make sense of the comment and then translate what I understood of this comment back.
Okay, and maybe you could add in your demographic survey the origin or the language, the native language of the person that could help you to just to validate or to ponderate. I don't know how to say, but to be sure. Okay, we know we don't have the same language, even when we talk the same language. If we are English native or French native, sometimes it's not easy to understand us. But if you can add this kind of data in your survey, that can also help to maybe to have a distance, to take a distance with the results. And you could also, I found researchers that they use professional translators to validate if the survey is the same in the different language. So that could be a method if you need. I have another questions about the method, because you used observations, in fact, to in particular for capture the participants' attitude, and you use 3 categories: happiness, neutral, or frustrated. And in fact, you say neutral, it's when you are not able to decode the participants' facial expressions. So in fact, for me, it's quite not clear, because you maybe the participant is happy or sad, but it's not neutral. So for me, neutral, it's not the same thing that the observer didn't understand something. So do you think these data are really relevant for your study? Because you put the result in the appendix, and in fact in the manuscript I didn't find really I didn't find the result. You only say, okay, they are very happy to use mixed reality or virtual reality, but we don't know if it's a context, if the observer it's in good mood this day and in bad mood the other day. So how could you reduce the subjectivity of this kind of observations? And in your case, in your experiment, do you think it's really useful to observe this kind of elements, or maybe the survey is just enough and objective data like times or other elements are more relevant?
Yes, for the first part of the question, I think it would have made bigger difference if we had some kind of cameras that had face detection, which monitors the facial expressions of the participants and how many seconds they are smiling or they are sad or they look frustrated. And that would have been more objective than only my subjective view of the participant if they are coming and doing it, if they are looking happy or looking frustrated, or if they're like doing like this or like thinking like that. Of course, this is subjective, and that's why, that's answering the second part, I put it in the appendix, because I just had this to supplement the main justification, the main sentiment of the participants, which was decoded in this justification. I just had this to see if it matches, if I'm correctly looking at the same things that are matching. So that's why I put it in the appendix, because I thought it's not a primary result of the experiment, it's just a secondary result which confirms the hypothesis that where you are using, let's say, virtual reality, the verbal comments from the people were like, wow, I've never used this before. Same thing with mixed reality. I got one participant that told me, this is my first time to use mixed reality glasses. I feel like I'm Tony Stark, like Iron Man. So there are some participants that were fascinated by the technology. At the same time, they were really happy about using the technology for the first time, and it was much apparent than the other ones that you couldn't decode. Are they happy? Are they frustrated? And that's why I left it out. If I could go back in time 3 years, I would have invested maybe in a couple of camera devices that take video of the whole experiment. But the other issue is that in Germany we have a very stringent personal laws. I cannot take video, and if I'm taking video of 100 people, then I have to take 100 pieces of paper and have them sign these papers that I won't use the video and I will delete it and all the stuff. So I thought this would be making more work from me than it will be bringing from benefit.
And I think there are many scientific issues about this topic, so I think it's for another PhD if you want.
Yes, exactly.
But I think you have also to take into account the cultural aspect, because people don't express the same feelings with the same facial expressions, for my opinion. Okay, thank you for your answer. Maybe I think I don't have many times. I have two other questions. The first one, you talk about immersive series prototyping benefit and drawbacks. Do you take into account, or the participant maybe take into account the environmental impact in the drawback?
Well, I didn't take the environmental impact in both the benefits and the drawbacks, because at the current situation, before that I was discussing it, that of course the devices, after 2 years you have to update them and then you throw them away, because then the devices are not up to date anymore and you cannot use them. But at the same time, at the current situation where we are all sitting at home, to say we are not flying, we are not traveling, so it might be a much better solution to wear a virtual reality glass, to beam myself to your meeting room and sit together with the virtual reality glass. And this will overcome then the environmental costs of these glasses, because first I will save up the trip that I'm going there, I will save up the time that I'm going there. And at the same time, imagine if you're on a company and you want to train your employees. Before COVID, it was easy. You sent employees from all over the world. Let's say the training center is in Germany. I sent all the employees to come to the training center. We had 2 weeks of training, and then I sent them back. They teach their colleagues there in the company. But nowadays, I send this I send it with a DHL package with all the information, and then they have to learn by themselves there by using the virtual reality glasses. That's why I didn't take it. I just put it at the end that this makes it easier to understand, that it's not co-located anymore, that the language barriers and the location barriers are taken out.
Okay, thank you. It's a global answer. You suggest to replace travel and trip by virtual reality. Okay. The last questions. It's more global reflections about your understanding of two keywords: conventionals and immersive. In fact, I think we don't have the same understanding of immersions. You give the definitions coming from Marc Palot and Simon Weschir. You said, okay, if you read a book, you can go in immersions. It's immersiveness. And in fact, exactly, this is this slide. For my side, simulations could be something like immersive or could generate immersive experiment and also verbal experience or paper experience. So do you think we could replace conventional by low-tech, for example, and immersive by technocentric or technological service prototyping approach, and maybe try to promote immersive service prototyping in a more global way, using, as you suggest at the end of your PhD, finally, a mix between low-tech and technical or very technical approach?
Great question, because that was exactly what I was thinking about in the past couple of months. Because immersive, when I mean here immersive based, I wanted to add to it technological immersive based service prototype. So that means that this immersion is based on a technology. It's not based on the way of giving the prototype, like verbal, like you said. If you are sitting in a presentation and the presenter is very taking us in a story, you could be immersed in the story. Or even if you're reading a book, like you said, like a paper, you could be immersed in the story as well. So that's why I find it, thank you very much for the two definitions that you give, the low-tech and the tech-centric. I think that they give a much better understanding if we talk about the global picture. Instead of going to conventional, which can say traditional, conventional, but I think low-tech gives a better dichotomy of the forms itself, and at the other hand, technology-centric immersive service prototype would give a better understanding of which technology is used in these forms.
Okay, thank you very much, Abdul. For me, it's a very great job, and thank you for your answer. And thank you so much, Madame la Présidente.
Thank you, Laurent, for your questions. And now we will listen to the second examiner, who is Dr. Olivier Chrisman.
Thank you. So, first of all, I would like to thank you, Abdul, and your supervisor for the timing to participate in this PhD committee. Just a few words on you before talking to you about your work. I had the pleasure to provide you a little help when you set up your experiment in Laval, and I was able to observe your professionalism and your great motivation, because you had a very tight schedule with only a few days in Laval and a lot of participants to test. And so I can say that I esteem you a lot for your work and all your human qualities. I know you have done a big amount of work during this year, both in your work in the University of Wageningen and also for the progress of your research. So, first of all, I want to congratulate you for the quality of your work you're presenting today and you transcribed in your manuscript. And also for the concrete results you obtained with Liber, an initial partner, because it's a very big result to help this company to understand what is service prototyping, and the result is that they hire 2 persons to work on that, so it's a very good result. And so for your presentation, I could say that I appreciated a lot because it was clear, pedagogical, and presented with conviction. I think it complements the manuscript very well because you focused on key points, experimental conditions, results, while being complete and accurate. So it was a very good presentation for me. And if I work in the immersive technologies, I must admit that I was not completely familiar with the concept of service prototyping. Or at least I imagine that when thinking about a service, I think about something more general, like car pooling service, car sharing service, and not directly on all of things like assembly guidance. So I learned a lot from your manuscript and your presentation on this point. But I have also some questions and comments that I will share with you. My first questions was on the cyber sickness. You work in the VRSP condition, cyber sickness. And I want to know if you get some explanation from the participants, what was the causes of this sickness?
So first of all, I would like to thank you so much for your support and the experimentation. As you said, I had only 5 days in Laval and 5 days in Angers, and I was able to finish 24 participants in Laval and 24 in Angers, and I couldn't have done it without your help and support. I had almost 9 hours of experimentations every day, so it was a pretty tight schedule. So as you were saying, the cyber sickness, the causes of the cyber sickness, I got some answers from participants that said that they just got the feeling that they are encapsulated in something and that they feel that they are totally closed. And this was one comment of one participant. Another comment for one participant, he said that he felt like he was dizzy. He felt like he wasn't standing on the floor. He felt somehow untangled with the world at the moment, and he had to take off the glasses directly. Another participant had actually made the whole virtual reality sequence, and afterwards, when he took off the glasses, the cyber sickness came into effect. He felt like he was not balanced anymore, and he couldn't stand. And what was more strange is I had 3 or 4 occurrences of cyber sickness by using mixed reality. So even in the case of the semi-immersiveness, because I thought it was only in the case of the fully immersiveness, as you can imagine, wearing the virtual reality glasses, you don't see anything outside the glasses. So, but when you're wearing the mixed reality glasses, you're seeing outside. So I thought it would have no cyber sickness, but it actually occurred that 2 of these participants, they were dizzy after using the mixed reality. They said that this information, that the continuous stream of information overloaded their brain functions and they had to rest somehow.
Okay, and because regarding slide 26 on the UX survey rating curves, we saw that VRSP appears to be a good SP, maybe in the middle one.
Yes.
Even if performances are weaker than the other immersive service prototypes. And how do you think we could improve the VRSP prototype to allow better quantitative results, performances or less errors? Or
I think, first of all, to improve the virtual reality service-based service prototypes, we have to make it more seamless. The device has to be better. I used in my experiments the HTC Vive. Now we have the HTC Vive Pro, which is a bit better. We have also the Cosmos and the Focus Pro, even at the university, which has a higher latency, which has a higher frequency rate. So the better the device, I think the better the experience will be, because we will maybe get less cyber sickness when it's faster, when it's better. Another thing is to have maybe to scan the room that we are in. So let's say I'm scanning the service lab or I'm scanning the Laval Virtual Lab, and then I will put it on the virtual simulation. So instead of having a clean room for the virtual simulation, I will simulate the real place that the experiment is taking place. So when they wear the glasses, they don't see any difference from where they were. And I think that will make a major difference in the performance in virtual reality service prototype.
Okay, and thanks. I have a question about the number of participants. You said in your presentation that 133 participants was a limitation. But for me, I think it's a big amount of participants, further that we are used to do in Laval for our experiments. And maybe it could be a limitation for the validation of the model, maybe, but I think for your experiment, it's a very, very great amount of participants. And you say that in your manuscript, you speak about a threshold at 100 participants, which seems to be the low limit to conduct an experiment. But why do you consider the number of 100 participants to be so important?
Because I wanted to have a statistically valid experiment. I didn't, from my literature research, there was no study made that had more than 100 participants. There were always 40 participants, 30 participants. So I thought to put myself away from all the other studies and to have a better understanding of the topic, I had to have more participants, to have a bigger data set, and to have a better understanding of the topic.
But in the other studies you mentioned, did they perform to obtain statistical results or not?
Yes, but only with 30 participants. They said that 30 participants allow them to have 80% of the statistical validity. So they said it's okay with them to have 30% or 30 participants only.
So I have a second sub-question about the number of participants. The question is on statistics. You present percentages as indicators of the differences in performances or in answer to questions. But why didn't you make inferential statistics to compare and to obtain statistical validated differences between the different service prototypes?
So you mean why I didn't create somehow a form of comparison between the different statistical of different prototypes?
Yeah.
I thought that comparing them like, So for each of the performance, for instance, of each prototype, I have these observation metrics that I had for females, males, and professionals and students. And I had the same thing for the UX results. So I have 15 questions, and each of the results I had at the same time. So if I did the same thing for the statistical analysis to compare each of them, if they are statistically valid, I might have found more information. But I thought if I statistically validate the model that I took out from these 5 models, it would be enough, and that I will concentrate more on getting the information from the UX surveys, the justifications like this, and comparing the different metrics that we have with the different identifiers like the female, males, the professional, and the students.
Okay. I have one question on the validation of the model. You write in your manuscript that you use the PLS method, and I'm not really familiar with this method, and I would like to know if in the PLS method you only test the links you're trying to validate, so the causality relation between the items, or does the method also give the other links that are not necessarily relevant, such, for example, as a reverse causality relationships?
Yes, for the PLS, it's made for prediction. So the first step, I have to define the outliers that we have. Second step, I have to refine them and then validate them, interpret them. And the second stage is to make predictions on these outliers, look at which deviations I have, and then complete them with together. So basically making this analysis by going from the problem gap to the idea hypothesis to the experiment to the modeling and having the prediction at the end. I used PLS with the smart PLS because it allows us to have to compare the coefficient together and have a better understanding of the model and to be able to validate the model, because we don't have a dependent construct on each other. And we also thought that by using PLS, we'll be able to deal with these outliers and also have the regression that it's made for those particular variances.
Okay, and I have 2 last short questions. In the manuscript, you mentioned the SPAM model, service prototype acceptance model, but I don't have the feeling that you mentioned it afterwards. What does it refer to?
Yes, it refers to the future work. I forgot to mention this is in the future work. I'm working on a new journal paper with other colleagues to create the service prototyping acceptance model, because it's also lacking in the literature. I didn't want to mention it here because we're still working on it. And we are trying to create this acceptance model that companies and researchers could use to see if the service prototype is accepted or not accepted.
Okay, and last question. And I have, in each condition, for each service prototype, participants have to perform a disassembly and assembly task, and just I wonder why did not you just do an assembly task? Why perform the disassembly and assembly task?
Because in a service situation, usually you get a machine and the machine has some kind of fault, and the service technician has to first disassemble the part, look what is wrong, and then assemble it again. So I wanted to simulate as much as practical as possible.
Okay. So it's okay for my questions. Thank you a lot, Abdul.
Thank you so much, Olivier.
Okay, thank you, Olivier. And more generally, I would like to thank the first 4 jury members for the extent and the depth of their questions. And Abdul Rahman, you've already done a great job answering these questions. And now I will listen to your supervising team. So hopefully they will not have as challenging questions, but who knows? So stay focused. And now, please, I would like to give the floor to Professor Dr. Christian van Huizen from Virtonghen University.
Thank you, Madame la Présidente, for the opportunity to give my statement here. Thank you, Abdul, for the interesting presentation reflecting all the work you did in the past years on your topic here. It was really a pleasure to work with you during these years on the projects together, and also to supervise this thesis, which is a quite important topic also to me. For myself, I'm involved in research and practice also on service innovation for around 20 years. And what I observe is that on one hand, we get much more complex services. We got solutions from product service systems. We got database services involving many parties and whole systems of involved parties. And on the other hand, what I see is that it really was difficult in the past to spread all over the companies and bringing the service innovation research into practice. And that's why I am convinced that service prototyping offers a lot of opportunities because it allows hands-on following on iterative processes for designing services. However, we have to face some challenges here. You also mentioned that we have intangible goods like services are, which are rather complex and consist of several dimensions. So this is a real challenge to put them into something that can be experienced during a prototype in this development process. And so that's what I believe, that the work you did is really important on this topic, especially since you combined it with another important aspect, the immersive technologies, which allow us to better experience things that do not exist at this moment. So what I appreciate very much is, for the first, that you really deep dived into the literature on service prototyping and gave a very good and, to my opinion, really a complete overview of the literature basis for service prototyping, and also gave this comparison of the underlying and also recent studies that go together with the topic. What is one outcome of this is already the differentiation and the taxonomy of different prototyping forms, which is an important basis, at least to know what types of prototypes do we talk about and which to use for what. So then in your research, I like very much the approach to combine these quantitative and qualitative data That was really convincing to me, because we have some also hard facts like the failures, like the time, like the questions they put, which give a very good insight how things work in this way. And well, what was also a very good supplement from my point of view was the industrial workshop that gave very good feedback from industry. And this is to me also already a proof of the practical relevance of this topic. You mentioned that the company, which is already quite a big company, employed people now for service prototyping and also for immersive technologies. So they really took this impulse and put it for them into practice and really put it up with manpower. So comparing these different prototyping technologies are important for me to allow us to choose preferable technologies for certain purposes in prototyping in the future. And this is the major contribution from my point of view to put forward the future of service prototyping, which depends on the appropriate technologies, methods, and tools. Well, that's these are my impressions and ideas from the work and also your presentation. I want to thank you again for this excellent work, which is to me the important contribution also to our work on service prototyping and on the several projects we have in the recent years. And I would like also to take the opportunity to thank the colleagues for this first joint supervision with Fortingen University and the very good cooperation we had. I'm sorry, I think my camera stopped somehow, but I hope at least the voice was okay. And well, thank you.
Thank you very much. Okay, so now we will listen to Dr. Marc Palot, also one of the supervisors of this work.
Thank you, Madame la Présidente, to give me this opportunity to provide my remarks and comments. But first of all, I would like to congratulate Abdul, not only for his excellent presentation, but also for his great contribution to this particular field of service prototyping. Personally, it was a pleasure to be guiding you in this demanding exercise of the PhD that was supposed to be a 3 years exercise that has been leading to some more than 3 years, because it is this demanding exercise, and at some stage it is not always a piece of cake to turn that into a thesis and do the proper synthesis of the work and so on. I would recognize also your ability and your responsiveness to the remarks and to the comments and the speed at which you are learning, but also because you are a very mature student, because you are a professional person, and this is also extremely recognizable from the outside. Then for sure, I don't have a particular question on your thesis or a particular question on your work. For sure, immersiveness is an extremely fascinating phenomenon, and we know it is something that is very subjective. We know that it is changing from one individual to another one. But at the same time, when we look at some people, and we can easily find out that they are immersed into something because they don't react any longer to any external event. So this is fascinating, and it is leading to some improvement into the way to foresee the potential design of new products, because also this prototyping is extremely useful today for products. But you have been demonstrating the usefulness also for the service prototyping, even if it is more intangible than the product development. And for me, this is really the challenge for all the industrial companies, because they did understand the usefulness of product prototyping, but it might be not so easy for industrial companies to foresee the benefit of service prototyping. And I guess that this is your challenge that you did not mention in the future work, but this is the challenge. How are you going to push your work, to push all this knowledge that you have created during your PhD to industrial companies? How are you going to convince them to enter into a kind of innovation service hall where they could give birth to service ideas, where the employees could enter into this hall, like in visiting a museum or something like this, that they can give their feedback about the service ideas to their company because they are employees of this company, but that they could participate at the same time to the innovation process, because engaging all the employees is also something that is absolutely necessary for companies if they wish to survive. So what would you recommend? So that would be my question and my final remark. What would you recommend for this kind of industrial company if they have for sure the financial capacity to make the investment into the immersive technologies, that they could set up kind of a service innovation hall where they can give representation of service ideas, and that the employees could visit those ideas, get an experience about them, and give feedback to their company?
Thank you so much, Mark. I'd like to thank you for all the effort and support you give me from the first time I met you in 2014 in the ICE conference. I remember it was my first international conference, and meeting you and meeting the ICE community ignited the passion for research for me that led to me starting the PhD. So I'd like to thank you for that and mentoring me all these years. So to answer your question, I think the most vital thing for companies to understand and to make their stakeholders, their employees to understand, is that you have to do it. You have to do service prototyping to understand service prototyping. Like I was explaining before, when the first time we went to Leap here, we went together, me and Christian, we presented for their higher up management team until the VP, I think vice president. And by the way, Leap here has 45,000 employees, just so you can imagine the size of the company. And the second meeting I went alone, and we had 2 service ideas, and I went with a bag of Lego blocks. And as you can imagine, in a traditional German manufacturing company, someone coming inside with Lego blocks, the employees were laughing. They were like, we are now going back in time and we're playing Legos. After the first 30 minutes, they started getting really into playing Legos and creating the blocks. After several hours, it was time for me to go because I had to catch a train, and they didn't want me to leave. They were like, oh, no, stay a little bit more. We'll just do one more exercise with the Lego, and then you can take it and I'll drop you even to the train station. So the whole idea here is that they have to first do service prototyping to know about service prototyping's idea. So my current work in the Smart Service Competence Center allows me to have this contact. I have several contacts in several companies that contact me about how to create a service, and then I invite them to the lab. Before now, it's a little bit harder. We do it online, or sometimes they even come to see the technologies that we have. And then I explain to them how they can start with the service prototyping, how do they have to just do it, to experience it, and then to iteratively improve on it.
Okay, thank you so much for this explanation, and I wish you and Christian a bright future in this field of service prototyping.
Thank you.
Thank you, Mark. Now we will listen to Professor Simon Richir. Simon, are you here?
Okay. This is a story of an Egyptian PhD student who works in a university in Germany and who one day decides to do a doctoral thesis with a laboratory in France and also invites the rapporteur from UK for the jury. Welcome today for the most international thesis ever defended in my lab. First of all, thank you, Madam President, and thank you to all the members of the jury who agreed to evaluate this work, especially to Laurent, who gave very good advices to Abdul. Secondly, thank you to Mark, who discovered Abdul a few years ago during the ICE IEEE 2014 conference, and that he co-organizes every year. Then Mark convinced me that Abdul was an outstanding student and that he was capable of carrying out this research project even while working in Germany. And then I trusted Mark, and that's the result today. Thirdly, Abdul, congratulations for your work and for that presentation, which we have rehearsed together several times, and which you have made more and more effective each time. It's great now. That's Abdul, great power, as Mark said. You propose to him to do something, and up, he does it in a very short time. It's great power. Just going to say a few words about Abdul's research work. This research work is very important for us and complements the work we are doing in Laval in the framework of the time to concept professorship, la chaire time to concept. For example, there's 3 points that I retain. First point, this work shows that the best results are obtained with mixed reality and augmented reality, even if the paper prototype remains very effective. This result is very important for us to focus our work on the user experience with augmented reality. For example, using the new HoloLens 2 from Microsoft, or we hope the Apple's future augmented reality glasses. Second point, Abdul proposes a set of factors to evaluate an immersive experience. These factors are classified into different categories. You have a dissociation from the real work, practical, emotional, and cognitive experience in immersion, immersiveness, as said Mark, effectiveness of the prototype, and finally the intention of acceptance or adoption. That's a very important factor. Then we'll use again these factors. Third point, Abdul demonstrates that the best approach for industrialists, because here in RZMT we work a lot with industrialists, as in Volkswagen, the best approach is to use both conventional and immersive prototypes to improve the process of prototyping and developing products and services. You would have thought that we would demonstrate the supremacy of immersive technologies because we are here in Laval, but it's not the case. Drawing on a sheet of paper or on a post-it is still relevant today, especially for those who have a talent for drawing. Then, to conclude, I will say that Abdul is a very nice person with whom it's easy and very pleasant to work with. He is also a fantastic worker. He works nights, weekends with enthusiasm and great motivation. I'm very proud to have been part of this international story, and I hope we'll keep in touch to work together on disruptive international projects within the framework of future industry. That's all. Madam President, I give you the floor to masterfully conclude this thesis defense.
Thank you. Thank you, Simon, and thank you, everybody, all the jury members. The timing is quite, it runs as expected, so thank you very much. You're all great professionals. And now I have 2 or 3 comments to complete the picture. I would also like to thank you once again, Abdul, for your presentation and also for the quality of writing of your dissertation, and also for including the links to the videos into your dissertation. It was very useful to to understand the situation that the participants had to face. And I would also like to emphasize the high quality of your state-of-the-art. My colleagues have already done that, but I feel like saying it again because it was your state-of-the-art was very well structured and very analytical. And this demonstrates that you yourself have a very structured and analytical mind. So it was striking. So congratulations for that. Otherwise, I have one big question and maybe two small questions. The big questions covers about all your work. It's related to your choice of positioning your contribution, your scientific contribution, in the field of service prototyping. And for me, it was not so clear what you experiment, what you design, what you experimented. It was not clear that it was a service, and I would I would like to know your your position. If I ask you to make a distinction between, for example, service prototyping and process prototyping, what are the differences? Why did you choose to position your work into the field of service prototyping instead of process prototyping, please?
So thank you, Madam President. So to have the simple explanation is that a service, we consider a service that it is intangible, and that as a service contains a process. So the process of the service deliverance, so from the customer, or sorry, from the service provider to the customer. So that means we have also actors. So the actors, which are the service provider and the customer. We have also the artifacts. So any kind of artifacts, whether it's devices, whether it's some kind of building, and at the same time the environment. So that means that the service contains already the process aside to other things.
Yes, but referring to OECD definitions, for example, they distinguish service belongs to the category of products. Okay, product means whether a good or a service. Okay, and process belongs to the category of business processes. Industrial processes belong to business processes because they are part of corporate activities. And when you mention the service provider and the customer in your definition and in this slide, for example, it's not clear for me who was the service provider in your experiments, who was the service customer. Is it really a customer or not?
Yeah. Yes, exactly. In my experiment, the customer could be also an internal stakeholder. So that means that in the case of training, for instance, which is a service, the customer in this case is also an internal stakeholder. So if I have a company and I'm trying to train my service technicians on how to disassemble and assemble this constructional part by using these different instructional guides to see which one is better accustomed for my employees. So in that case, the customers in that case are the internal stakeholders, which are the employees themselves. So that's how I decided to focus on services, because it includes a variety of activities and processes like maintenance, training, but I concentrated, like I said, in the research scope on the maintenance parts, because this is the heart of services, the heart of creating, going to the service technician, the parts is coming to them, they are fixing it and then sending it back and creating all the training it from the maintenance itself as well.
Okay, and I also have a side question which is linked to this first question. In your questionnaire, in your survey, you when you ask participants to rate the intention to adopt something, actually, I think you asked them to rate their intention to adopt the prototype, but not the service. Is that right? And why did you choose to assess the intention to adopt the prototype and not to adopt the service?
That's exactly right, because I wanted to select which type of prototype is more appropriate for that service. Because the service itself is very important. Maintenance, we all have devices and we all sometimes need to send these devices to get repaired. So the maintenance process is already very fixed, it's already well known. And through the baseline experiment where the participants completed the tasks without use of any service prototype, it showed that any kind of service prototype, whether it's paper-based, verbal-based, whatever, it would have been much better than not using any. So for me, it was much more important to see the participants, which one are they more convinced to adopt, which ones are they more willing to reuse afterwards, and which ones are they ready to recommend to others.
Yes, I understood the goal of your study to distinguish between the different types of prototypes. But it would be also quite exciting to be able to predict the adoption of the service and not of the prototype from your work on the prototype. So for me, the question of predicting the adoption of service remains open. Is that right?
Yes, I don't think that in my work I had looked at adopting the service itself, because I thought of it as a given that we have already the service. Yes. We now have to choose what kind of form or which kind of form are we delivering the service. But you are totally right. I could have first asked them if they could imagine themselves doing the task without the service. But I thought of it as already answered because of the baseline. But you are totally right. It's still open.
Okay, thank you. I have a last question. Actually, it extends Olivier's Olivier's last question regarding statistics. And okay, so Olivier asked you why you did not perform inferential statistics to compare the different types of prototype. For example, to perform pairwise comparisons between prototypes. I have heard your answer, but I would like to rephrase the question. Actually, can we go to slide number 27, please? Yes, okay, that's just an example. I would like to know whether there is significant difference in immersiveness, for example, between augmented reality service prototype and mixed reality service prototype. Is the difference significant or not in immersiveness?
In immersiveness. No, yes. The difference is not significant. If we look at
how do you know that?
From looking at the ratings of the participants themselves. So looking at the significance of
the ratings. You mean you performed an average, a mean, and you decided that it was not different.
Yeah, because the numbers were higher. So 1.11 compared to 0.91, it's higher, but not compared to, like, let's say 0.17 in case of the mock-up service prototype.
Yes, I like you, Abdul, but we cannot take it for granted. I would have liked you to provide the numbers demonstrating that it was not significantly different, because I cannot take it for granted. Okay.
Okay.
You see what I mean?
Yes, I understand. I think you mean something in the shape of this slide. I'll just take it up. Yeah, this one. Something in this form somehow.
Well, no, because here we don't have the different. We don't have the comparison between.
You are right. You are right. Yes.
Prototypes.
Yes. I understand now. I understand now. You are totally right.
This is not the same kind of statistics.
Yes, you are totally right. I now understand
maybe I think it's something you will have to perform if you want to publish these results, if you want to properly and definitely publish these results. I think that any journal reviewers will ask you to perform these inferential statistics to know what differences are statistically significant and what are not. Because it's okay, your table is nice, but we cannot take it for granted that, okay, I think it's not so different because it's high. And yes, here it's different because it's low. It's not the way we are expected to read science. I think, okay.
Yeah, I totally understand your question, because I actually am planning to do this. I answered also in the Revier's question about the service prototyping acceptance model, and that's the exact plan of doing this journal paper for the acceptance model, is to compare each of these together to have this acceptance model complete.
Okay. Okay, so thank you. This was my last question. My fellow jury members, do any of you have an additional question or comment?
It's okay.
Nothing from my side.
Okay, for everybody, I assume. So now the jury members, we will switch to another channel in order to deliberate in private. And after that, we will get back to this channel to, well, to conclude with you. Okay?
Perfect.
So see you in, I don't know exactly.
15 minutes, around 10 or 15 minutes.
Oh, yes. Okay.
See you soon.
See you soon.
Thank you again.
Thank you very much, Madam President. Thank you, everyone in the jury.
That is back. I've just on my second screen. Okay, good. I think. Okay, we're online. It's not the same picture. No, I think there was a problem, technical problem. I think. I think it can be recorded, I think. Okay, excuse me. Okay, that's good now. It's online. Okay, Mrs. President, it's up to you.
Okay, thank you very much. Abdul, well, the jury first acknowledges the high quality of both your dissertation and your presentation today, which both demonstrate your pedagogical skills among other skills. You were also quite brilliant in answering the numerous and tough questions of the jury, and with a great reasoning each time. So congratulations for that. But what the world will remember, what we all will remember as key contributions of your work is threefold. The first point that we will remember is the extent and the accuracy of the state-of-the-art that you performed, and in which we all learned something. So that's great. The second point we will remember is your methodological contribution. We said that it was not only extremely sound, it was kind of unique what you performed on the methodological side, because you performed it in a systematic and logical manner. You both worked with participants in laboratory, but also in a workshop with industrials, so that was kind of impressive. And finally, what we will remember is the way you managed to bridge the gap between two very different universes, the academic world and the industrial world. And this is also impressive and very precious in our fields of research. So subsequently, for all these reasons, the jury awards you, Abdul Rahman Abdel Razek, the degree of Doctor of ESAM University, prepared at École Nationale Supérieure d'Arts et Métiers in the specialty Industrial Engineering. So, congratulations.
Oh, thank you so much, Mr. President, members of the jury. Thank you so much. It's a pleasure working with every one of you, and it's a pleasure seeing you, even if it's not in person, if it's not only online. It's still a pleasure to see each and every one of you. I'm really thankful for all the time and support that Christian, Simon, and Mark as supervisors gave me. I'm also very thankful for all the support from the ICE community and everything that the ICE community provided throughout the years, from support. And of course, I would like to thank Kulwant, Laurent, Olivier, Davy, and of course, I'd like to thank you as well, Madam President.
You're welcome.
Okay, you have a great lot of congratulations on the YouTube channel. You will see that later. What I propose you is to make a picture, a screen capture. I will have a screen capture of my screen, and oh, everybody, cheese. Yes. Okay, give a smile. Okay, 1, 2, 3. Abdul, smile.
Yes.
Okay, it's good. It's good. Good. Okay. Great. Now we have maybe Abdul, you prepare a drink for us, but it's a problem.
Yes, I have here the bottle, but it's
yes.
hard to send it online.
A virtual drink.
Yes.
No problem. Okay, then
I can try to put it in the webcam, but I don't know if it will work.
we have our everybody has a mug or something. I'm not saying mug. Okay. Then thank you again. Thank you for the jury members. Thank you, Mrs. President, for that great job. And thank you again, Abdul, for your job, because you were the man in stage today. Okay, see you soon. Thank you, everybody. And
Congratulations.
Thank you. Bye.
Okay,
so
thank
much.
you. Goodbye.
Thank you, everybody.
Have a great
Goodbye.
day. Stay
Thank
healthy,
you
stay
very much.
safe.
Good celebration.
Thank you,
thank
Mark.
you.
Thank
Thanks,
you very
everyone.
much.
Thank you.
Goodbye.
Bye-bye.
Goodbye.